Hello there. In this class we are going to discuss how do we convert number systems from binary to decimal and decimal to binary. So I'm not going to create videos on all of these binary numbers, all of these system conversions, because you will find a lot of videos on them and I see them as very easy things to do. So that is why I'm only going to perform binary to decimal conversion and decimal to binary conversion only, because I think these are the most important ones, and after this video we will get into the other videos, other topics of DLD. So I don't want to waste our time while discussing all of these things. So without further ado, let's try to understand the binary to decimal conversion using an example. So I've got a number here. If you can see, this is the number 1001.01. Now if I want to convert this number into decimal, so there's a small technique that I've created here. You can create a table like this. You can simply arrange the numbers just like this. You can also create a separation between the two parts of the number by placing the radix point right here. Now the least significant bit that we call to the rightmost bit of our number, so this is our non-fractional part, so we will call this our LSB, or the least significant bit. So simply I'm going to arrange my bits like this, and from the least significant bit I'm going to write 2 power 0, and then while going towards the left side I'll increment the numbers. I'll increment the exponent, 2 power 1, 2 power 2, 2 power 3, and if I've got more bits I'll increment these powers just like that. So now while coming to the right side of the fractional point, you will definitely decrement the power. So if here the power is 0, here the power will be minus 1, minus 2, minus 3, and so on. So now what would you do? You have created a table like this. Now you will see that what is 2 power 0? 2 power 0 is actually 1. So if I multiply 1 with 1, I'll multiply these two numbers with each other. Now if I multiply 1 with 1, I'm going to get 1 definitely. So 2 power 1 is 2, but when I multiply it with 0, it will become again 0. So similarly 2 power 2 is 4, but if I multiply it with 0, it will become 0. Now 2 power 3 is 8. If I multiply it with 1, it will become 8. So if I add up all of these things, I'll get 9 on this side. Now going towards the right side of the fractional point, now if you will see here we will find 2 power minus 1, which is I think 0.5, but when I multiply 0.5 with 0, it's going to be 0. Now what is 2 power minus 2? 2 power minus 2 is going to be, I think, it's going to be 0.25. so this is 0.25. now if I add these things up, I'm going to get 0.25 here. So simply I've got two numbers here, one is this one and one is the left one. So simply I'm going to merge those numbers with each other, so I'm going to get 9.25, which is the binary decimal equivalent of this binary number. So this is how using a small table just like this you can convert your binary number into decimal number. Now if you have got this number, let's verify it by converting it back into binary. Now to converting a decimal number into binary, you will use the simple LCM technique that we used in our childhood. So what are we going to do here? Now while converting from decimal to binary, you need to do two separate tasks for the fractional part and the non-fractional part. So let's see for the non-fractional part, what are we going to do for that? Now we will write our 9 like this, and we'll keep dividing it on 2. So if we divide it, simply 2 multiplied by 4 is going to be 8. So if there is a remainder, we will write the remainder here. So in this case there is a remainder which is 1. So 2 4s are 8 and 1 is the remainder, so I would write it right here. So again 2 multiplies by 2, 2 times 2 is 4, so there is going to be no remainder, which means 0, and 2 multiplied by 1 is 2, so there is going to be again 0 remainder. So now what will I do? I'll arrange these numbers in this sequence by starting here to this one, so it will become 1 0 0 1. Now I have got the non-fractional part. I have converted 9 into 1 0 0 1. But what about the 0.25? For converting 0.25, I am going to multiply it by multiply it by with 2. So what am I going to get if I multiply 0.25 with 2? I'm going to get 0.5 definitely. So now what am I going to do? I'm going to write this part over here, and I'm going to write this 0.5 part or 0.5 part here, and I'm going to multiply it again with the 2. So what am I going to get right now? I'm going to get 1.0. Again I'm going to place this number here, so it will come here, and again 0.0 will come back here, and it will be multiplied to 2. So I'll get 0.0 by multiplying it with 2. So again I can write this 0 here, and I'm going to repeat this process until, like, whenever you want to stop it, you can stop it. But if you see 0 here, you don't need to go forward, because it will keep coming 0 whenever you try to solve it. So simply I'll write these two. So this is going to be actually 0. So simply the first 2 bits are enough for me in this case. So I'm going to write 1001.01. So this is going to be my final answer, the final equivalent, binary equivalent for this decimal number. I converted this non-fractional part separately using LCM, and I converted this part of the fractional part of our number by using this kind of technique. So this is how you can convert decimal numbers into binary numbers, and you can convert binary numbers into decimal numbers. So after this class we are going to start Boolean algebra. So keep yourself with us and keep following us. Thank you.